So this is the second in a series of videos on simulating OFETs, and I think OFETs are quite fun because they're 2D devices. You have to simulate them as a 2D structure, and it sort of introduces lots of interesting concepts about how charge flows in space, and a great fun device to simulate. And this is all really coming off the back of this paper, which is the first outing of the 2D solver really of gpvdm in a full paper. And the contribution here was of gpvdm was effectively generating some current plots as a function of position and trying to understand effectively disorder and what that does to current flow in the device. So that's that paper. You can read that and download it if you want. So back to the tutorial. So we looked at this device last time, which is a top contact OFET. And the thing about this, you've got current coming at the top, and it goes. So there's the source, comes in there. It'll go along this interface here, or it'll go along here, and come out this contact here, which is the drain. And you control how much current flows along there by changing the gate voltage. And if you put a large voltage on the gate, then you generate sort of effectively an inversion layer, which means there's lots of charge sort of out this semiconductor insulator interface, and the device turns on and it conducts. And that's a very interesting class device, and it's quite a common one to make. And you generally make it by evaporating these contacts onto it. Now that's all very well and good, but there's another class device which is also very interesting that I want to talk about in this video. So this is also an OFET, but instead of having these, let's just move this back here, instead of having these contacts on the top, what you do is you actually have them on the sides. So here if we look at this, we've got a side contact here and a side contact here. And these are generally buried contacts. So the way you'd make these is you'd effectively deposit, say, a thin strip of gold here, and then you would evaporate your material here, the blue layer, and you put the green layer on. You put the red layer, then you might put the next contact on the top. So they're sort of generally, these contacts are not stuck on the side like they're shown here, but they're sort of buried within the structure. And with this you can get injection from the side of the device, and it can be much more efficient, and there's other reasons why you might want to do this, but I won't go into here. So this is all about simulating, this video is all about simulating these device structures with sort of side contacts or buried contacts. So you can get both the last simulation, this simulation, from the model, so download it from gpvdm.com, and the examples are in OFETs, and there's the side contact one that we're looking at now, and there's the top contact that we looked at in the last video. Just to keep things simple, I've got 4 layers, 1, 2, 3, 4. This is the gate, this is the insulator, and we've got 3 semiconductor layers of different mobilities. So the layers are defined in the layer editor, so there are the layers, so we've just got thicknesses, and the contacts are defined here. So here the source is on the left and the drain is on the right. You can have it in other places, but I won't. So let's just go ahead and run this and see what happens. So there we go, it's finished. So let's just look at the output of this simulation. It's in the snapshots directory. So let's look at current. So this is is that current? Yeah. So this is electron current. So let's just turn the heat map on so we can see what's going on. So what this is, I'll explain what this is. You've got can I move this? I'll zoom it out. There we go. Right. So we've got current coming in the source, going along here somehow and getting out the drain there. Now I set these layers to have different mobility. So this one's got a low mobility, this one's got a high mobility, and this one's got a low mobility. So if we look in the parameters editor, we can see here that this layer has this mobility which is low, this one has this mobility which is high, and this one has this mobility which is low. So at low gate voltages, which is what we're at in this picture here, effectively what current's going to do is going to come in and conduct along this high mobility layer and then out of the drain. And as we increase the gate voltage, the current flow is going to be more and more sort of dominant along the insulator conductor interface there. So effectively the current's going to be pulled down to that interface there. So let's just have a look at what's going on in this picture. So this is a very low gate voltage. You can see we've got current. So current coming in here, which you can look at the axes later, but that's that point there is here, and this side here is here. So current's coming in here along this layer and out there. Then as we step forward in the gate voltage, so let's just bring this up a bit. As we step forward in the gate voltage, this conduction region, which that centre layer of the device, is being pulled down. So charge is now flowing, as I said, straight down here, along this interface and out this contact. So let's just step forward in current. So there we go. So current's being dragged down one side along the, and that's the insulator there. You can see that's the insulator because there's no current in it, along here and out this contact. So you can look at this and sort of play with all this in 3D. And, you know, if you want to plot other things, I don't know what you might want to plot. I don't know, say conduction band or something like that. Where's conduction band? EC. Or actually, why don't we look at? No, let's look at the conduction band. EC. There we are. So you can sort of look at the potential profile across the device as you're playing. So that's the gate, and we're sort of applying a big voltage to the gate, and you can see sort of how potentially the device reacts to what you're doing to it. So that's it really. So I'll just run through a couple of more things. So the voltage on the contacts, this here was set at ground, so that's ground. This here is set at 15 volts, and this sweep on the gate is set in the JV editor, and that went from 1 volt to 15 volts. So that was the sweep. And the output, just look at the characteristic output curves. So we've got JV contact, which is the, oops, so look at the outputs. We've got JV contact 0, 1 and 2. So the contacts are labelled source 0, gate 1, drain 2. And you can just look at these. So this is the source, the drain, and the gate will be flat because obviously there's no current going through it. So that's it really. It's a little mini tutorial on simulating buried contacts in OFETs. I hope you found that interesting, and thank you very much for listening.